Like we have been already able to discuss metals, right? So metals, we have already discussed that how metals have how their arrangement of particles, how their bonding actually affects their properties. Similarly, we also were able to talk about why metals, what are the shortcomings with the metals? Why are they not very applicable? Why their application is difficult in the industrial and daily use is because of their reactivity. They're very reactive. They react with air and water, and they easily corrode. They easily wear out very quickly. So they have, and they are not hard. They're soft because of their properties. So we said that they are mixed with, those metals are mixed with either other metals or non-metals to form alloys. So alloy, what is an alloy? An alloy is a mixture of a metal. You have to keep that in mind. A metal, a pure metal, with one or few other elements. They could be pure metals, they could be non-metals. And such some examples of alloys are: bronze is an alloy of copper and tin, brass is an alloy of copper and tin, zinc, sorry, stainless steel is a is an alloy of iron, chromium, nickel, and carbon. This is what gives them the shiny. Chromium gives them this shiny and non-corrosive appearance, and the carbon gives it strength, and iron also gives adds to its strength. All right. So we have already discussed that. Other point is that they are mixtures. We have to keep in mind alloys are mixtures. It is not the metals are not chemically bonded together. The elements that are mixed together do not chemically bond together. They are just mixed together. All right. Random arrangement of particle takes place and they are mixed together, but they are not chemically bonded together. All right. So why are alloys better than metals? So we were able to discuss that metals can be made harder. Why are they better? Because metals were soft. We already discussed that. They can be made harder and stronger. Brass is stronger than copper and zinc individually, right? Brass is stronger, and this they become stronger. This strength comes from where? This is due to the difference in size of copper and zinc. Remember when we were discussing metals, we said that the metals, there is a particular arrangement. They are arranged in layers. The atoms of metals were arranged in layers, and there was a sea of electrons in between them, and all of them were of same shape and size. All right. For a same metal, for let's say copper only, so all of the atoms are going to be of same precise shape and size, right? All the atoms are going to be of same shape, so it is easy for them to slide over each other. But if you mix different, like if you mix copper and zinc, so the copper is going to be like this and the zinc is going to be like this, bigger than that, or it could be different in shape and size, so they are different. You see. So this difference in the shape does not allows them to slide over each other. They cannot now slide over each other easily. They cannot. Do you understand this? It's like the bigger atoms, the the bigger atoms act as anchors. They do not let they do not let these layers to slide over each other. All right, do you understand? Obviously there's a sea of electron for some. There might not be a sea, there might not be a sea of electron, but they do not allow them to slide over each other. Is this clear?
Yes, sir.
All right. And we know that metallic bonding is not going to be there. When metallic bonding is not there, they're going to lose all those Like they're not going to have electrons like that. Why? Because there's no metallic bonding. Right? Metallic bonding always takes place within an element of a metal, within the element of a metal element. All right, not in different. If there are two different metals over there, metallic bonding is not going to be there. Metallic bonding only takes place in only one type of atom, which means only one element. If there are two different elements over there, metallic bonding is not going to be there. Is that clear?
Yes, sir.
Now, difference in the size and the shape of different atoms when they are mixed together of metals, they lose their ductility, they lose their malleability, they become harder. Why? Because this ability to slide over each other is not there anymore. Is this clear? All right. In sometimes it is also
Yes.
in some places you're also going to see metallic structure drawn like this. Sometimes they are going to ask you in your exam for sure that which one is a pure metal and which one is an alloy. They're going to give you, let's just remove all the positive signs. Just we're going to become confusing for us at the moment. Just they can ask you which one is an alloy and which one is a pure metal. All right. What do you think? Which one is a pure metal? Which one would be alloy? Yes, Alishba, what do you think? Which one of them can be a pure metal, A or B? Hmm? The answer is very simple.
Sir, A.
A is a pure metal. Why? A pure metal will only have one type of atoms in it. And this is the one, only one type of atoms are going to be there. And this is the one which will have metallic bonding. This can be a metal. This can be something that is conducting electricity. This could be something that is harder, stronger, high melting, whatever it is, all the properties that metal have. But this is not a pure metal. This could be an alloy, because if one of them are metal, they could be alloy, or it can also be an ionic compound. But ionic compound, they are not arranged like that. They are arranged in lattices, right? They are arranged like that in lattices. Do you understand?
Yes.
They are arranged in lattices like that.
Yes.
All right. So you have to make sure. Definitely, they are going to ask you all of those things. You tell a difference between an ionic compound. They what they are going to say. What is which one is the copper? Which one is the brass? And which one is the salt? So the brass is going to be an alloy, right? Which is going to have such structure. Copper is a pure metal, will have this structure, and the lattice is going to be for the salt. So you should be able to draw that. And then they can also draw molecules to ask you. All right. Inshallah, we are going to be practicing that. We'll get aware of that, inshallah. All right. So the next point, why? So this is the first point. Why do we have? Why do we prefer alloys over metal? The second point that we have is that alloys are alloys are more resistant to corrosion. corrosion, right? An example is pure iron. If you take pure iron, it will form rust very quickly and it will be destroyed, finished in few weeks. But if you take stainless steel, it will last for many years, right? You understand this point?
Yes, sir.
And the third one rather, an important one is that alloys have lower melting points. So you can say, rephrase this, alloying can be used alloying can be used to lower the melting point of a metal. Melting point of a metal. All right. Or it can also be used all right. Alloys can also be used to lower the melting point of metal. Is this clear?
Yes, sir. Yes, sir.
Alloys and their application. We have brass. Brass is 70% copper and 30% zinc, right? It has a very attractive gold color. Has gold color. All right, attractive gold color, and used in decorative coins, making coins, musical instruments, and it can also be used in decorative ornaments, show pieces or decorative stuff, right? Then we have stainless steel, something that is very commonly used. It has 73% iron. It has chromium, which is 18%. It has nickel, which is 8%, and carbon, which is 1%. All right. It is resistant to corrosion, used in cutlery, utensils, right? Pipes, making pipes, and all of that. It is what is the why you can be asked in your exam, why is stainless steel better than any other metal that can be used? One of the best answers would be resistance to corrosion. Resistance to corrosion. All right. Is this clear?
Yes. Yes, sir.
All right.